Okay, so let us continue with solving the ax equal to b to find the value of x. So what we can do here is to use the inverse function to find the value of x. If the number of equations in a system equal to the number of variables and the coefficient matrix has an inverse, then system will always have a unique solution that can be found by using the inverse of coefficient matrix. So what we need to do is to find the coefficient inverse of coefficient matrix, and then we will get the answer for the x, the variable matrix. So x will be equal to A inverse multiplied with B. How do we get from the left side to the right side? So proving the equation. So let's say ax equal to b. So if we want to find x, means that we want to eliminate a here. So how to eliminate a? We have to multiply with its inverse to get an I. So multiply a inverse from the left side on both left hand side and right hand side. And then what we will get, a inverse multiplied by a is equal to, yes, this part will be equal to I. So I of x is equal to x itself. So x is equal to a inverse multiplied by b. That is why we can find the results for x, the solution for x, by multiplying with the inverse of a with b. Remember, we can find the inverse of matrix using three methods. The first one is use adjoint method. The second one is by using the property of AB equal to KI. And then the last one is to apply the elementary row operation, which is ERO. Let's do one of the example. So we want to solve the following equation by using the inverse matrix method. So what we have here is system of linear equation. The first thing we have to do is to convert into the matrix form of ax equal to b. So after converting into the matrix form, so what we have, the matrix A is equal to 3, 1, 2, 3, 2, 2, 1, 0, 1. And then matrix X is equal to x1, x2, x3. And then matrix B equal to 11, 10, and 5. So what we want to do to let matrix X as the subject. So how to eliminate matrix A? Remember, we can apply the inverse on both sides. So just find the inverse of matrix A. So how to find inverse? We can use three methods. But for this one specifically, we can use the adjoint method or ERO method. Okay, let's try to find A inverse. So, what is the formula for A inverse? Remember, A inverse is equal to 1 over determinant of A multiplied with adjoint of A. So, the first step, we have to find the determinant of A. So, we can choose any of the row or column. So, here, what is the results? For this one, we choose the third row. Why? Because we have an element 0, so that we can reduce the workload. So what is the determinant? So we get a determinant of A equal to 1. Okay, we are done with determinant. The next step is to find adjoint. How to find adjoint? Remember, adjoint of A is equal to cofactor transpose. Means that we want to find the cofactor. What is cofactor? The minus with the sign. So let's find the minor of each of the position. So we can write down all of this in the matrix form, and that by deleting its respective position. Okay, so what we get as the results for the first one will be 2. The second one will be 3 minus 2 is 1, negative 1. And then negative 2, negative 1, 1, 1, negative 2, 0, and 3. All of this we have to transpose because adjoint equal to cofactor transpose. So what is adjoint? We get 2, negative 1, negative 2, negative 1, 1, 0, and negative 2, 1, 3. Okay, let's continue. What is our A inverse? It's 1 over determinant 1 multiplied with the adjoint. So what is the results? We have the same as the cofactor transpose or adjoint, which is equal to 2, negative 1, negative 2, negative 1, 1, 0, negative 2, 1, 3. So now we can continue to solve the x. How to solve the x? just multiply A inverse with B. So what is A inverse? Copy the A inverse we got earlier, multiply with matrix B. So multiplication between two matrices. What will we get as the results? So for the first element, we will get 22 minus 10 minus 10, which is equal to 2. And then negative 11 plus 10 plus 0 will be negative 1. Negative 22 plus 10 plus 15 is equal to 3. So we have the matrix X equal to 2, negative 1, 3. So to find the value of x1, x2 and 3, we write down the conclusion as therefore x1 equal to 2, respectively x2 equal to negative 1 and x3 equal to 3. Okay, let's do the continuation from the question in part 1. So the first part, we want to find the system of linear equations and then convert into the matrix form. Now, question C asks you to verify that the inverse of matrix 2, 3, 4, 2, 3, 5, 1, 2, 2 is equal to this matrix. So, what is this matrix? The one we want to find the inverse. This is actually matrix A, right? Here. So, what we need to do is just to find the inverse. So, if you notice, we don't have 0 here. Means that we have reduced into 2, 3, 5 only. Okay, so let's okay, that is for question C. How about question D? The question D asks you to, by using inverse matrix. So inverse matrix means that inverse matrix we find in the question C, solve the above system of linear equation. Above system of linear equations. So what we need to do, remember, to solve X, it should be A inverse multiplied by B. So we have A inverse, we just need to multiply with B. So let's do this. So we have matrix A here and we have the inverse here. So we don't have to find the inverse from matrix A. Why? We know the properties of matrices, of multiplication between matrices, that the fact when A multiply with its inverse, what we will get as the result, it should be identity. So we should check whether the multiplication between A and N inverse we get identity. So after you do the multiplication, directly we get identity as the result. So we can confirm that 7, negative 5, negative 3, negative 3, 2, 2, negative 1, 1, 0 is the inverse of matrix A. Okay, so what we can see from here, actually this question have give you some hints to solve the questions. So we don't need to find the A inverse already. So we don't have to do the adjoint method or ERO to solve for the A inverse. We just have to use the inverse given in the questions. How about D? Now we just have to solve for X, Y, Z. So we just have to substitute the A inverse into the results. So A inverse multiplied by matrix B. So do the multiplication. So we will get the result is 5, 4, 8. So the conclusion is, what is X? X is the number of serving of cereal X. Y is the number of serving of cereal Y, and Z is equal to number of serving of cereal Z. So write down the conclusions. So the result is 5 number of serving of cereal X, and then 4 number of serving for cereal Y, and then 8 number of serving for cereal Z. Okay, so this is the next question, example 3. So let's say the question gives you matrix A and B, and then they ask you to find what is A multiplied by B. So we just have to multiply between two inverse. And then the next part is to find A inverse. So let's see the result for A and B first. And then after that, hence solve the following linear equations. Means that to solve the following linear equation, we should use the previous result from the first part of the questions. So what is A multiplied by B? So from here we can see that after multiplying the matrix A and B, we get a result of 16, 0, 0, 0, 16, 0, and 0, 0, 16. So what are these mean? Okay, this is actually, yes, it is 16I. So 16 of identity. So what we get as the result? AB is actually equal to 16 of I. So this is in the form of AB equal to K of I. So what we can do for the next part of the question? The next part of the question asks you to find A inverse. Means that we can use the properties of AB, KI. So from the previous result, AB equal to 16I, we can say that we can find A inverse directly from these properties. So what will it be? So A inverse should be 1 over 16 of B. Okay, by applying the properties of AB, KI. So how to find the A inverse? We just need to multiply 1 over 16 with the matrix B. So every element should be multiplying with 1 over 16. Okay, so don't forget to multiply with every element in the matrix B to get the A inverse. Continue with question D. So the question D asks you to find the solution for the system of linear equations. So we have the equation already, and then we can write down the equation into matrix form, because it's easier to solve by using matrix form rather than using the simple simultaneous equations. Okay, so we have the matrix A multiplied by X equal to B. Now we know that X can be found by multiplying A inverse with B, and we know what is A inverse from the previous questions. So let's just find what is X. So X is equal to A inverse multiplied by B. So what is A inverse? A inverse is 1 over 16 of matrix B from the previous question multiplied with B from the system of linear equations. So don't be confused with these two B. So this B is from the previous question, which is we want to find the AB. But this B is actually the constant matrix from the system of linear equation. We can use C, we can use D as the representation, not the matter. Okay, so we just need to multiply all of these elements and multiply with the constant 1 over 16. So what is X? So for these questions, we are multiplying 1 over 16 with the matrix B first. But actually you can skip multiplying with the constant. What we can do, we just multiply between matrix B and B. B from the question and B from the system of linear equation. So we multiply this first, and then after that finally baru kita multiply with the constant 1 over 6 for every element. So now we get the result X is equal to 11 over 8, 3 over 4, negative 3 over 8. And then don't forget to write down your answer X for X, Y and Z in a. So therefore, X equal to 11 over 8, Y equal to 3 over 4, and Z equal to negative 3 over 8. So please write down the answer in this form. Okay, we actually finished with this chapter. So now you can try to do this exercise. Try to solve the following equation by using the inverse matrix method. So for the inverse part, you are free to use any method. Okay, but for this one is actually we can use the adjoint or ERO. But I know you guys won't do ERO method. I know why. And then you can check your answer here, where x1 equal to negative 2, x2 equal to 1, and x3 equal to negative 3. So for ERO, for this subtopics, actually we have another method, which is the Gauss-Jordan elimination method. But for that part only, we are going to study in our tutorial or our lecture face-to-face. Okay, so you can try to do question tutorial for this subtopic, and good luck.